so let's look at another example of calculating an improper integral. Right, so in this case, we're looking at the integral from 1 to infinity of ln x over x squared. Right, so again, we have to express this integral as a limit. Right? And again, now we have to calculate this definite integral, right? And we have to use integration by parts. Right? So what we'll get having done that is minus ln x over x, right? Minus 1 over x. Right. So the integration by parts you do here. And you'll choose your f to be ln x and your g prime 1 over x squared. Right. So, and with these choices of f and g prime, you'll get this result. Right. So, substituting in the bounds, we get the limit as t goes to infinity of that right. So now let's see. Well, 1 over t is going to go to 0 as t goes to infinity. Right, so there's no problem there. 1 is just going to go to 1 as t goes to infinity. So again, there's no problem there. So those terms are taken care of. And the one we have to worry about is this ln t over t. Right? Remember, as t goes to infinity, ln t goes to infinity, and t goes to infinity. Right? So you have to be very careful when you calculate that limit, right? We have to use L'Hopital's rule. So let's go ahead and do that. And so our I is limit t goes to infinity of minus ln t over t, right? And then we have plus 1, right? Because 1 goes to 1 and 1 over t goes to 0. Right, so now using L'Hopital's rule, it means we differentiate the top and we differentiate the bottom. So we differentiate the numerator and the divisor, and we take the limit again. Right, so differentiating minus ln t, that gives you minus 1 over t, and differentiating t gives you 1. So we basically have 1 over t. And as t goes to infinity, right, what's going to happen to 1 over t? Right? 1 over t is going to go to 0. Right? So this limit is 1. Right? So the integral is 1. The integral is convergent. Right. And that's how this problem is done. So again, right? Firstly, you have to express your integral as a limit. Right? You have to find the definite integral. Right? And then you have to take limits. Right? And when you have things like infinity over infinity, or infinity times 0, or infinity minus infinity, you have to be very careful. Right? You can't just make those things 0 or infinity or 1. Right? You have to calculate those limits, and typically the method for doing that is L'Hopital's rule.